What does it mean to be proportional? What does it mean to be proportional? Yes. No, not quite. Alvin? Okay, so if you were to graph a line, that line would go through the origin. It's linear, okay? And if you were to make a ratio out of y over x, the ordered pairs on the point, they would be, they would be the same, like, if it was 1/2, then it would be like 4/8, the ordered pairs, like 4/8, that would be y over x. So the y over x is constant, the ratios of the ordered pairs. All right, so I just wanted to bring that back to you because, we did a whole section on proportionality and stuff like that, but then we kind of skipped over and started doing like equations and inequalities and exponents. Now we're going to kind of go back to that, and because this section and the next couple sections have proportionality in them, but because we already did them, I'm going to skip those sections, okay, but they're still going to be included in your information that you should know. All right, so now we're going to focus on slope. So the next few days is just going to be slope. So we're going to get slope from a graph. So slope is the ratio of the change in y, which is the rise, over the change in x, which is the run. Okay, so if you think about a graph, so here's a graph. So if I'm going from here to here, this is the y-axis, and so that's the rise. Okay, and then this is the x, so this is going to be like the run. Okay, so rise over run. So it's this distance, that stands for change in y over this distance, change in x. Okay? So we will see, like, slope is like the steepness of the line. Is it very steep? Is it flatter? So you can look at the slope, like think about the basketball courts. You know how it drops off right there? That's a pretty big slope, right? If you were running full force and you fell off that at the edge right there, it's not a steep slope where you're going to keep on running. If you're running full force and you hit the edge right there, the basketball courts, what's going to happen? You're going to you're going to eat it. All right. So, yeah, I got to test something. All right. So we're going to watch a little video.
Welcome to the Adventures of Slope Dude. Meet Slope Dude. He loves to ski. We are going to follow him, and he'll teach us some important aspects of slope. This is the course he's skiing today. What he says will teach us about slope. Always remember that Slope Dude always skis toward the right or eastward. When he starts out, he's going uphill. It's hard work. He says puff, puff, positive as he goes up the mountainside. Puff, puff, positive. Puff, puff, positive. Now he's at the top. It was puff, puff, positive all the way up the mountain, but now he can look forward to the downhill. On the way down the mountain, he says, nice, negative, nice, negative, nice, negative. And now, after the downhill, he's in for the hardest part of the ski route, the long, flat part. He says, this is zero fun. This is zero fun. This is zero fun. As he finishes the flat part, he doesn't see well ahead, and all of a sudden he comes to the edge of a cliff. It's straight down. He finds a slope this straight down and so frightened is he that he says the worst curse word possible in math and in algebra. Undefined! This has been the Adventure Slope Dude. Remember always what he said during his ski trip. Up the hill or up the slope, he said, "Pup."
So, think about, and you might want to write these in your notes. Just do a quick little, coordinate plane, make a positive slope, and, make it positive. So you always read a graph left to right, just like, you read a book. So Slope Dude would be over here. So what's he saying? Positive. So left to right, what's Slope Dude saying? Nice negative. So what's he saying? 0. So the slope is 0. So I'm going to tell you slope is, the abbreviation is M. So M would be 0 there. M, it's going to be negative. M is going to be positive. And then here, M is what? Undefined. So it's not 0, because 0 is not undefined. Undefined. Okay, so just make those, put these little tests. Make those 4, they don't have to be like, just make them real quick. So I gave you a note sheet. You should have that out in front of you. But here are some steps. Write these down real quick. Pick a point. No, you can write in your notes. Pick a point. Rise up or down. Okay, depending on, if it's a positive or negative slope. Count the spaces to the same level as the other point, then run left. Well, I always run right because I read it left to right. Okay? So you're going to run right and then count the spaces to the next point. Okay, so I'm going to show you, I don't think you have this one, right? So I'm going to show you what this is like. Now, if they don't give you a scale, means there's no numbers on here, then it's a 1-to-1 scale. Okay, you just count up by ones and count over by ones. So you pick a point where this line crosses the lattice points of the coordinate plane. So they gave me 2 points already. So I'm going to use these 2 points. So all you do is you start from the point that's the most left, count up. 1, 2, 3. So I went up 3. I don't have to worry about the scale. And then over 1. So my slope is just 3. Okay? If you're not graphing it, obviously you're not graphing it because it's already graphed. If you're not graphing it, simplify it. If you're graphing it, you will want your slope as a fraction. Okay? So, so again, you're always going to go from left to right. And think about what Slope Dude would say. What did Slope Dude say? So this is a positive slope. Question? The what? The what? M equals 3. No, you mean you want to go right here, right? Yeah, No, I just wrote it. Yes. All right. Okay, so you have this one on your note sheet, right? Okay, so we're going to find 2 points, and you can find any 2 points. So I want you to identify a few points on this graph. So here's a point, here's a point, here's a point, here's a point, here's a point. I can pick any 2 points, but you want to pick, usually when you do slope, if you use the 2 closest points, if you use 2 points that are really close, then most times you don't have to simplify. Most. Not all. Because it depends on if there's a scale. Sometimes you do. But if you pick this point and this point, you're definitely going to have to simplify your fraction. Okay? So we're just going to pick, we're going to stay in the positive. We're going to go from here to here. So from here, you're going to rise up. So when you rise, you're going to be on the lattice lines. So you're going to rise up. Now, there's 2 ways you can do this. I'm going to show you the way that I expect you guys to do it, but I'm going to show you another way. Okay, I went up 1, but how much is that 1 worth? 5. Okay, and then I'm going over, and it's going by, how much am I counting by on here? Look at the scale, look at the lines. How much are they counting by? 1. So you just count. 1, 2, 3. So your M equals 5/3. And then if you do go from left to right, if you go up, it's going to be positive. If you go down, it's going to be negative. But you can always check Slope Dude and see to make sure that it's positive. Got a runny nose. All right. So I'm going to show you another way to do this. So how many did you go up? You went up 1, right? 1 unit. You can also times that by the scale. What's it being counted by? 5. So this would be 5. How many did you go over? 3. What's the scale? 1. Did I get the same answer? Yes. So if you're not one to, count by numbers, then you can do it this way. But I would expect that most of you are going to say this is 5. All right. So look at this one. Let's do another one together. Turn to your shoulder partner and discuss what kind of slope do you see with this line? All right. What kind of slope, Meta? Negative slope. So if you look, and if I put Slope Dude right here, nice negative, right? So let's identify some points. I have a point here. I have a point here, and I have a point here. So now we're going to rise down. So what on my rise, what's my scale? Going by 2. So even if the line is not marked, you still got to count it. So this would be 2, 4, 6, 8. So if I go down 1 box, get to this level, I went down how much? Negative 2. Okay, so when you go down, it's negative. So what's my scale on the x's? 1. So you just have to count. 1, 2, 3, 4, 5. So M equals negative 2/5. Okay? So let's look at what would happen if I went from this point to this point. Let's see. How many am I going down? 2, 4. So I went down 4, so it's negative. And how many am I running over? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Can I simplify that? So I can divide them both by 2. So I get negative 2/5. Did I get the same thing? Yes. All right. What about if I went from this point to this point? What's it going to be? Negative 2/5. It's going to be the same, right? I go down 1 over 5. So no matter what 2 points I pick, as long as that line is linear, it's straight, right? Then I'm going to get the same slope. If it's a curved line or jagged, it's not the same slope. It's not the same steepness. All right. So try this one out. You have this one. Try that one. Okay, let's see. See how well you did. So you're going to pick 2 points. So I'll pick here and here. I'm going which direction? Up, so it's going to be positive. So and it's going, what's the scale on the rise? 1. So 1, 2, 3, 4, 5, 6. And what's the scale on the run? 1. So 6 over 1 is just m equals 6. Raise your hand if you got that right. Okay. Yes. Okay, so the question was, do you have to put m? Yes, because you have to tell me it's the slope. M stands for slope. And we'll talk about y and m in a couple days. All right, so do this one. So, there's many points you can pick, right? So, first of all, what's slope dude doing? What's he saying? So I would definitely put that right from the beginning. But if you rise down, then it's be negative. So what's my scale? 2. So I rise down 1, so it's going by 2. And what's my scale here? So I'm going to come by 5. So 5. Negative 2/5. Did you get that? Yep. Okay. Now, guys, on the notes, it said run, right or left, right? I mean, could I take these 2 points and technically go up and to the left and get the same? Yeah, because if I went up, I still went 2, right? And if I went to the left, I still went 5. But you just have to know that the rise is always on the numerator. This is the rise over run. Okay? Now, and then you have to know that if you're going to do it backwards like that, that this is a negative slope. Okay? That's why I kind of tell students, just go to, up or down, and, read it from left to right, and always run to the right. If you always run to the right, then when you go down, it's negative. Okay? But look at your graph. Just stop and take a look at your graph. What kind of slope? Oh, it's negative, and put that negative side right away. All right. Do this one. Okay. Okay, so let's put a couple points. What's the scale going by on the 1? So, first of all, I look, it's a negative slope. So, 1, 2, 3, 4 over, what's the scale going by? 2. over 2. So that would be negative 2 over 1. So it checks, but should be negative 2. So m equals negative 2. Okay? Now, if you leave it negative 2 over 1, it's not wrong, because slope is a fraction. It's just that when you're not graphing it, you don't need it looking like that. You can put it like this, yes. All right. What slope? 0. What slope, Jude, saying? 0 fun. If you're skiing, is a 0 fun, right? Because it's a lot of work just to, get across that. So, all you do, m equals 0. Yes. Okay, now, guys, let me show you why it is 0. How much did you rise up or down? So, 0 over, how much did you run over? 1. What's 0 over 1? 0. So you don't need to do that. You just got to know that's 0. Now, what's this one? So you would say m equals undefined. Okay, then let me show you why. So, how much did you rise up? Let's count. 1, 2, 3, 4. Oh, how much did you run over? Can you divide by 0? No. So, this is undefined. All right? So, undefined. Do that one. And then do the next one. This one. Undefined. And Nevin, what's this one? So m equals 0. Okay? That's it.